I'm David Hahn, the Craig M. Birch Dean of the College of Engineering, and I'd like to welcome everyone to the third installment of our new lecture series. Our goals remain to share our research success and impact with our alumni and friends, many who generously support the college and have actually helped make this happen. Today's talk is entitled Fast Forwarding to Driverless Cars and Smart Traffic. I think we've all seen the explosion of technologies in our cars, including blind spot warnings, lane departure warnings, auto steering corrections, auto braking for collision avoidance. And I think we might all have to think a little bit about what stresses us the most. Driving next to a Tesla in full autonomous mode while the driver is reading a newspaper. I've actually seen that. Or someone driving a normal car while totally absorbed in texting someone. We know humans are imperfect, but what about machines? On the other end of the spectrum, how many times does it seem like you hit every single yellow light when crossing town, while other times it's green all the way? Imagine the opportunities that technology and big data offer to make the road safer, more efficient, and less stressful. So today, you will hear how University of Arizona engineers are partnering with municipalities at all levels to advance automation around cars and traffic. I'd like to invite my two colleagues to join me. And I'd like to introduce them. Thank you for coming. First, I'd like to introduce Dr. Jonathan Sprinkle. Jonathan earned his Bachelor of Science degree from Tennessee Tech University and his master's and PhD degrees from Vanderbilt University, all in electrical engineering. He currently holds the Litton Industries John M. Leonis Distinguished Professorship Chair in Electrical and Computer Engineering Department. He is a University of Arizona Distinguished Scholar and serves as the interim director of UA's Transportation Research Institute. Welcome, Jonathan. I'd also like to introduce Dr. Yao-Jan Wu. He earned his Bachelor of Science in Civil Engineering from National Central University in Taiwan, his Master's of Science in Transportation Engineering from National Taiwan University, and his PhD degree in Environmental Engineering with a focus in transportation from the University of Washington. He is currently professor in the Department of Civil and Architectural Engineering. He directs the University of Arizona Smart Transportation Lab and is faculty advisor for the UA Institute of Transportation Engineering Student Chapter. Welcome both of you, and thank you for joining us in what I think is going to be a very entertaining discussion. Now, before we dive into the research aspects, I'd like to sort of frame this a little bit in focusing and looking at our educational mission. How might educational institutions such as ours, keep pace and prepare our students to move into the autonomy and transportation workforce beyond their university days, supporting local communities or commercial ventures? Jonathan, I'll let you answer, and then Yao to share his perspective.
Yeah, I think one of the great opportunities has to do with taking what we're learning in research and applying that into the classroom. And especially at my undergraduate levels, my students can attest that the data that I gather makes its way into their homework assignments, and the challenges that we pose are societal challenges. The more they think about what they can do to improve society, the better stewards they'll be when they graduate.
Excellent. Yeah, what is your perspective on that?
I want to echo what Jonathan just mentioned. I do think technologies is really important for students to learn. So we always incorporate technologies in my classroom. So we teach them how to use technology to solve real world problems. Thank you.
Excellent. Good, preparing them really for those next steps. Thank you. So before we get into our question and answer session, I'm going to invite Jonathan and Yao to share their screen and talk us through a brief slideshow to frame our follow-up discussion. So I'm going to turn it over to you both.
Excellent. Thanks very much. And we're really looking forward to being able to talk with y'all today. And I'm just setting a timer so I can keep myself on time here, and we can leave plenty of time for questions and answers. One thing that I'd like to reinforce, and we're going to talk about this kind of throughout the slides, is that transportation is not just cars. But I want to open up with a car. This is a 1928 Model A Ford Phaeton. And when I was young, my great-grandfather used to tell me about when he used to take this car from Sevierville, Tennessee to Chattanooga. And he described those trips as taking about 12 hours. 12 hours and 12 flat tires. And now that journey takes just a little bit more than 2 hours. It's faster, but it's not just faster because tires are better. And it's not just faster because cars are more reliable, although both of those things are true. It reinforces the fact that the roads have changed and how we move around has changed, which is to say mobility is more than just cars. Traffic is more than just congestion, and decisions are more than just algorithms. Another example from almost 100 years ago is this one, where a Rio Speedwagon, depending on your musical choices, you may have a different name that you would use to classify that car, drove from Omaha to Denver in just a little bit less than 1 day. It took them longer than 20 hours. But in this case, we are talking about mixed traffic. We have human-driven vehicles, relatively slow speeds, horses and cars on the road, and all of the management of the infrastructure was negotiation between vehicles. Contrast that to the vision that we have of the future, where we see almost all the cars computer-driven, fast travel, almost 100% autonomous vehicles, and the infrastructure is vehicle-to-vehicle and vehicle-to-infrastructure communication. In the past, if we think about this as a transition, in the past we had things that were almost exclusively static in their infrastructure. Negotiation was handled visually and everything was human controlled. In the future, we see that we're going to have dynamic infrastructure, network negotiation, and almost all of it computer controlled. So the research question is, how do we negotiate this transitory period from what we've depended on and been familiar with to what we don't know how to expect? And the answer is in the fundamentals. It's new networking, new dynamics, understanding of how data, policy, and mobility all play a role. I want to open with some research that's ongoing from one of our faculty members, Larry Head from Systems and Industrial Engineering, who's been working for years in a holistic approach, a full life cycle from research to algorithms. He's working with multimodal traffic signals, which allows you to change how the signal behavior should be based on the traffic that's moving through the area. As more vehicles become connected, as more information comes through vehicles such as buses or trams that are moving through the area, it becomes easier to make sure that vehicles that have a lot of passengers get priority as they move through a corridor. And it also makes it very straightforward to think about how you could take care of emergency vehicles as they come through. But there are still plenty of research questions here, such as what do I do if a tram is coming through at the intersection the same time as a fire engine? They both think that they have the right of way because they're important to come through. So we need to make sure that as they negotiate that, that technology is there to help instead of getting in the way. Larry manages a test bed in Anthem, Arizona that allows for real world application of these kinds of theoretical advancements. And it's important that we have test beds to do this work. I'm going to highlight one particular test bed that I'm familiar with, which is the Cognitive and Autonomous Test Vehicle. You can see that test bed in action here with some undergraduate researchers who came for the summer to study what autonomous vehicles should be doing. It's really cool to put somebody in the car and watch the steering wheel turn with nobody in the front seat. But we've gone beyond demos in this work. We're able, and you'll see on the right-hand side here, Charles Johnny and Yesenia Velasco, who were able to show that their work allowed them to really test the robustness of a controller that needed to depend on noisy data in order to make the car move around. And they were able to do that in just a span of something like 6 weeks. I want to add that this was made possible by the generosity of many donors from the College of Engineering, including Ed Biggers, who was able to donate some funds that allowed us to purchase the localization equipment so that Yesenia and Charles could do this without worrying that they were going to run into something or somebody. But as I said before, transportation is not just vehicles. I want to think about those vehicles also as moving controllers. And on the left-hand side of the screen here, you see something that may look like a silly example. It's a bunch of cars driving around in a circle. It turns out that if you put humans in a circle and ask them to drive around, they will create traffic waves. And what we were able to show is that if you add some intelligence to one of those vehicles, and that vehicle is controlled in the right way, it can actually dampen those traffic waves, which has the advantage of making traffic better for everyone in the flow. And you don't know why. It's just better because the car in front of you is not stopping as much. On the right-hand side of the system of the screen here, you can see what happens though if we were to take the vehicles of today and just ask them to all drive behind one another. If you were to do that, you might find out that the adaptive cruise control of the last vehicle will shut off. It'll get so low that the cruise control doesn't know how to respond. And this raises the challenge that we can't just take what we're buying off the shelf and apply that. We need some research that allows us to advance this. I mentioned before some of the opportunities that students have in my class. I want to highlight here some work that's gone over since 2013 for undergraduates from across the US who've been able to come and engage in a research experience. I think the big message here is that these students have been largely successful in going on to graduate school, and something like 80% of the students who have graduated and applied to graduate school have received funding so that they do not have to incur future debt in order to move along in their pipeline for their careers, which can be amazing. If you want to find out more about what those students have done, check out the catvehicle.arizona.edu page, which will allow you to follow up. I've highlighted here some graduates that are from the University of Arizona who participated, but there are many other students, 70 plus now, who've gone through the program, including last year. One other thing that I want to highlight as we transition between vehicles and autonomy into infrastructure is what's the role of policy. And the role of policy really has to do with how can we incentivize people who would normally drive a car to be a part of the transportation infrastructure without adding to congestion. And some work from Christina Kearns that's funded by Caltrans is looking exactly at this, that if we change the incentive to have a car at the place of your residence, that can actually change how you respond to the desire to drive. So if you can't find a place to park your car, it might be easier to find a way to ride into work with somebody else or to take the tram. And so what she's been able to find out here is that if you reduce the dwelling spaces at residential developments, it can reduce vehicle demand by roughly 10 percentage points in LA, which is a fantastic potential result. I think this will lead me now into introducing Yao to be able to talk a little bit about some intelligent infrastructure.
Thank you, Jonathan. So entire Arizona actually is my test bed. I'm kind of lucky to have the multiple agencies to work with me. So as you can see, my research has been focusing on transportation system measurement and operations, TSMO. The goal is to improve traffic, mobility, and safety. So my team has been actively working with more than 10 transportation agencies, including City of Tucson, Arizona DOT, on solving and mitigating real-world traffic problems. First, my team helps these agencies collect traffic data in a much more efficient way. Traffic sensors and technology are not just plug and play. Most people thought they just plug it, buy the expensive devices, they will be working smoothly. They will not. So we've been helping the city jurisdictions to solve this problem. Second, I have been also working with the third-party data provider to collect statewide traffic speed data in real time, meaning that the tool we developed by my team is able to grab the minute-by-minute traffic speed data from more than 66,000 roadway segments in Arizona. Last, I'm able to safely and efficiently access agency's central data system to collect additional traffic data, including citywide traffic signal data, region-wide freeway sensor data, and the statewide crash data. So the next slide, I'm gonna show you some real-world applications of my research, including speeding zone identification, origin destination estimation. We know how travelers travel from point A to point B, which mode, in this case, this bike sharing system, to reach their destination. We also developed, we also developed online decision support tool for rate metering system for ADOT, and also optimize traffic signals for multiple agencies. As you guys can see in the video on the right-hand side, we actually went to the field and collect data to help the city to optimize their traffic signals. The most exciting thing is that the city took our suggestion, the City of Tucson took our suggestion to implement new technologies and strategies in real world. As you can see in the photo on the lower right side, so we actually work together to change the traffic signal head because we really want to implement new technology in the real world. Most importantly, my students learn a lot through the process. Also want to thank for their funding support. The next slide, I'm gonna show my colleagues, Dr. Chu. He created a strategy for mobility on demand. It's also the way to mitigate congestion by managing travelers' behavior. Most impressively, he did not do it on paper. He actually founded a company called Metropia, so he can implement his strategies in real world. This plot showing on this slide actually shows how this system can collect and processes the traffic data in real time and also shows how he works with Texas DOT to incentivize the travelers to change their traveler behaviors in this $20 million project. Quite impressive. So the next slide, I'm gonna show you CATS. Due to long-term collaboration relationships with multiple agencies, we have created momentum to create a new center, CATS, of which I'm the director. Building more roadways is definitely not a good solution for limited land and budget we have. For example, building an interchange could cost taxpayers more than $100 million. We would like to use a small portion of the money to form a center so all agencies can work closely together to make our life better. So as you guys can see, we have 4 co-member agencies in addition to University of Arizona. College of Engineering is a support sponsor for this center too. I'd like to thank Dean Hong for his support. And we also have project member agencies. They still continue project relationship with my center. And also we still continue working with academic partners, ASU, NAU, and other universities. Last, we also have industry partners. We're gonna expand our membership in the following years. Thank you. I'm gonna turn that to Jonathan.
As we move on, many of you may have driven freeways in Arizona before. This is such a vision of one. And you'll notice that whenever you're on the freeway, you tend to have your eyes kind of on the horizon. And that's where we are now. What's next? What's ahead? What's coming? And as we keep in mind this vision of a lane kind of moving ahead of us and allowing us to think about perspective, it draws on me wanting to ask, what are the pieces that we need to make sure are in place, not just for research, but for the students who will be graduating from our programs? We need to be able to think about how we're going to tie into themes in artificial intelligence and machine learning and automation. We are going to be making advancements in vehicles, advancements in simulation and testing, learning more about systems theory and system management. The future is going to involve more computer control, not less. It's going to have a role for new kinds of sensors, but also be tightly engaged with sociological factors to understand why people want to move around and what incentives they have. Our infrastructure will be more connected. And in order to make these changes, as Yao pointed out before, you can't just say we're going to build another road. You have to make sure what the community really needs and what's going to respond to the pain points that they have. Our approach is going to require more research infrastructure and better understanding of it. We're going to have to really think about what are the pain points that cities and local agencies are engaged with and understand more about the economic factors which drive many of our mobility systems. And think about what's the impact of this in terms of the energy that we so depend on when it comes to moving around. All of these depend at its base on understanding more about the data that are helping drive our decisions to make sure that we're not making that into a vacuum. And as we see each of these things converging, all of these fields moving further forward, we can also think about, as we remove data from the equation and think about what is that obfuscating? It's obfuscating all these other pieces that need to be there in order to be successful. We have to think more about how to reproduce our research results, how to control access to data that might have privacy concerns, how to take advantage of computational infrastructure that we have on campus, such as Cyberse, as well as making cloud analytics available for students who may not be able to buy expensive laptops, but have interesting ideas that deserve attention. So this builds into a larger scale vision of where we're going in the future, which is an institute that covers all of these areas, that provides a way to give mentoring to new faculty and students, to be able to curate data sets that are going to feed into new kinds of decisions, more interdisciplinary and convergent collaboration, test beds that are going to allow us to take ideas off the whiteboard and put them into practice, focus centers that can have something that has really a tight tie to the pain points of its members, and then finally being successful in sponsored research at a level that we can go beyond now. I think that ties up almost everything that we wanted to introduce here, and it should seed a great set of questions moving forward. I'll stop sharing my screen now, and I think we can move along.
Excellent. Thank you both for a really informative presentation. So we'll dive into our Q&A. Many of you pre-submitted questions, which I have pulled from, and in real time, we're also monitoring questions that you submit. So we probably won't get to every single question, but we're certainly going to do our best. Let's build right where you left off with your formal presentation. Now, what effect will driverless cars and connected vehicles have on the road and transportation networks? I'll let Jonathan address the connected vehicle aspects, and Yao can take the traffic network aspects. Jonathan.
I'd say in some ways the jury may still be out. So you can take this as a thought question for yourself. Imagine a future where it takes longer to get to work, but you don't have to pay attention to what you're doing. Would you move further away and be happier on the road longer if you can read the newspaper or shave or whatever you feel like you need to do? You might, and some people may make that decision. I think there was an experiment that was done at Berkeley's Intelligent Transportation Systems, where they just paid for Ubers for 100 people for a year. And that kind of mimics what it's like to have self-driving cars. And if you gave people free Ubers for a year, their miles per year went up because it seemingly didn't cost them their own attention. And so it's going to depend on a lot of societal scale factors as well. But I also think that the sensors that you need to make that happen will help not just in the vehicles behaving, but also help in new innovations in the transportation network that may offset those increases in miles, which may tie into what Yao's perspective is.
Yeah,
thank you, Jonathan.
On transportation networks?
Sure. Driverless car and connected vehicles, I think they will change the way we traditionally analyze traffic. So most existing textbooks and engineering design manuals probably need to be updated and revised or rewritten. Therefore, I think there will be something very interesting I see in the roadways. For example, we probably can see dedicated high capacity lanes just for driverless cars in the future. So our engineering students probably need to relearn everything after the graduate. Yeah, something new gonna happen.
Good.
Thank you.
Jonathan, we would guess that one potentially weak link in fully autonomous cars is the sensors. What generally happens to the system in the car status when we have a sensor failure? What are the approaches to dealing with that?
Yeah, it could be tempting to say we're going to use the same kind of approach that we've used in avionics for 70 years now, which is to have redundant systems. And redundant systems work really well, but they also cost a lot more. And so for car manufacturers who can sometimes balk at having a 50-cent increase on a control unit to say, oh, we're going to buy 3 radars to put on the front to make sure that if one of them fails that we've got 2 left over, that can be cost prohibitive. So what we're seeing instead is some ideas of graceful degradation. I know that the Toyota RAV4 that I drive will tell me every once in a while, because it's too hot outside, that's Arizona, it'll say, hey, your lane detection features are not working because the camera has overheated. So don't depend on that. Stop depending on that feature. And that kind of graceful degradation where the car can still work, but it can't take advantage of all of its sensors is really the path forward. And it opens up the idea to have some sensors that are maybe radar-based, others that are vision-based, others that may be sonar-based, depending on what you're doing and what your activities are.
Good, excellent. You know, Yao, in a city like Tucson, we have really large changes in traffic from summer to winter as people leave and then come back. So, you know, when you start to do a lot of your network optimization, how do you accommodate those changes? Does that present challenges? Does that present opportunities?
This is a great question. So seasonal and daily traffic pattern changes are actually quite common for a city, like city of Tucson. U of A has been working closely, my team has been working closely with the local jurisdictions to dealing with these issues, especially want to make them dealing with these issues more efficiently and effectively. For me, there are definitely many challenges. That's why I feel fortunate they work with the U of A on developing new technologies and the new solutions. So for me, these challenges are our opportunities. Thank you.
Excellent. I'm going to pull one quickly that was just submitted by the audience because a few people have submitted a similar question. You know, I'm going to let you both take an opportunity to dive into here. What about cybersecurity, right? We hear so much about hacking and you know, can someone take your car over? How do you deal with cybersecurity from a network perspective, Yao, or from a single car or multiple car connectivity, Jonathan? I'll let you go first, Jonathan, and then Yao, you can address the networks.
Yeah, the cybersecurity question is one where, again, we think we could maybe depend on stuff we know about encryption, depend on things we know about secure keys. And it should be that easy, but unfortunately it isn't, because if you start depending on the key of a car, you can just listen to the traffic long enough and figure out who the other cars are and imitate their keys. And one interesting approach that's being considered is to think about transmitting not just a message that you want the other car to hear about what you're doing, but a little bit of side channel information that you should have based on where you are. So it might be, I just passed a pole, or there's a car next to me who's doing this. And then the car behind you can figure out from its sensor suite, yes, that probably is that car saying those things. So in essence, what you're saying is, I want you to do this, or here's some information for me, but I'm providing something in a side channel that you should be able to validate that's not just a 64-bit encryption key.
Very interesting. Yao, from a network perspective, what cybersecurity challenges do you know?
Yeah, I really like this question, because in my class, I always use the example of the movie Intelligent Job. Is that possible to hack into a central system and turn all the lights green? The answer is no, it's impossible. If you guys don't want to know why, please join my class. I can explain more. So it's impossible physically, technically. And another way is that we do worry about people hacking into our central system. So nowadays, a lot of vendors, they have been preparing for this day will be happening. So they actually quite good about secure their central systems. Thank you.
Interesting. Jonathan, you know, there are many unique challenges around automated driving, as you know more than most. Particularly driving in rain and fog and snow, relevant to us, dust, you know, avoiding cars that are partially off the road. So how do you deal with these, just from a procedural perspective? Do you try to program every situation, or do you start to use artificial intelligence to learn outcomes from much practice, or do you merge the two kind of processes?
Yeah, there's a little bit of a merger there. Part of it is very hardware dependent, and this makes the electrical engineer in me so happy to know that we need mixed modality sensors in order to be able to overcome the limitations of one modality for another. Depending on our own sensors is important, but also radar is really great in some modalities. LiDAR can be great too, but LiDAR doesn't do really well unless you can see through fog. So as soon as you get fog or dust, LiDAR stops working really well. And that means that either you back off of that capability and say, I'm no longer able to do that kind of activity, or you transition to another sensor and maybe change, I can only do this up to say 40 kilometers per hour or 70 kilometers per hour based on the modality I have. But this is one of the key challenges in going beyond the SAE level 2 to get to SAEs level 3 and 4, where some vehicles are now. But it also requires a lot of human training to know where the limitations are. And that's also another challenge.
Very interesting. I look to you, Yao. The Tucson has recently incorporated what they call the Michigan left turn intersections. And I'll ask you to comment on how do you feel those figure into traffic networks and safeties and efficiencies from your perspective. And I had to Google it. I didn't know what a Michigan left turn was.
Okay.
Michigan left turn is basically, instead of turning left at an intersection, one goes through the intersection. There's a special designated turn lane where you make a U-turn and come back from the other direction. I know there's one on Grant down around First. And so, yeah, do you want to comment on the Michigan left turns intersections and your thoughts on them?
Okay, thank you. It's actually a tough question. So I thought about this for a second. Technical speaking, Michigan left turn intersections can improve traffic flow efficiency. Technical speaking, okay. But the potential downside is that it's challenging for road users to accept the new way of traffic control strategy, because people get used to what they get used to. So in order to ask people to change, they will do something interesting. Therefore, they might be something interesting will be happening in the road, on the roadway. So I can come on this from the technical side. Yes, it's improving traffic, but for political side, it's complicated.
That's interesting. Thank you. Jonathan, let's talk about the world of driverless trucks, what some people see maybe as low-hanging fruit, and that they operate on predefined routes, often on the interstate. What's going on? I know particularly we were asked, again, in the user submitted about TuSimple, the Arizona-based company. Can you give us a little insight into a status update on where they are, and how about issues of transfer to drivers in urban areas and such? So why don't you educate us on that important opportunity?
Yeah, I know about as much as everybody might who's read the public information on this, and it's really exciting what they've been able to do. I was checking in to make sure I was up to date, and it looks like they're actually running UPS orders right now between Phoenix and Tucson. If you've ever ordered anything from Amazon in the last, I don't know, 6 months, when we're all ordering stuff from our house, you may have had it delivered by a driverless truck on the way. And it's really exciting to think about that that's a possibility, because it opens up more freight to be going on at a reduced energy footprint. Because if you're able to anticipate the grade of the vehicle, of the road coming in front of you, or follow more tightly to the vehicle in front of you, you can get tremendous energy savings and also throughput savings. But in the larger world of trucks that goes beyond just a single company, I know the Department of Transportation was recently highlighted in an Office of Science and Technology Policy at the federal government level, that there's something like 20 plus federal organizations that are all coordinating on advancements that can be made in autonomous trucking to improve things for the economy and to make sure that a rising tide really lifts all boats, but also pay attention to the fact that it's not just replacing people, but that it's appending what folks can do who are in the truck and making it safer for when they're there, because there are those opportunities when you do need to hand off and have a qualified person behind the wheel.
Yeah, that's great. No, it's really, really fascinating. It can be, as you say, very, very impactful. I guess particularly in the pandemic, when we're just ordering everything from home, right? We have to move all those goods around, and we need to do it efficiently. Yao, let's talk about new businesses that might be needed to, pick up where you and your students and colleagues leave off. So how do you see new businesses playing a role in the future transportation infrastructure? You mentioned Metropia. You can comment on them or others.
Okay, so as I mentioned earlier in my presentation, building more roadways infrastructure is really costly and not realistic in the long term. So I'm glad you mentioned Metropia. They use MOD, Mobility on Demand technologies, to incentivize travelers to change different routes, change the way they depart their home, when they depart their home, when they arrive their destination, optimize the routes. So the Metropia company founded by Dr. Yao-Jan Wu will be a potential solution to future traffic problems without adding more infrastructure to our land. So that's something I want to emphasize. I do think Metropia will be a really good example, setting up a really good example for future business to follow. Yeah, thank you.
Good. Jonathan, the big question, the $1 million question that often gets asked is, what are the estimates of numbers of lives that can be saved as we transition to sort of autonomous smart vehicles in a big way? I'm sure you've thought about that or looked at some of that data. I'm sure there's not an easy answer.
Yeah, certainly more than 30,000 lives every year, since as many data points as I could find are lost in traffic fatalities. Vehicle fatalities. And I remember about 7-8 years ago when I was applying for some federal funding, I did a really close look at the speeds at which those things were happening. And there were still a significant number of fatalities less than 20 miles per hour. And so what I'm hoping will happen is that you'll see more advancements at low speeds where you can have automated braking that will prevent pedestrian accidents, prevent vehicle-to-vehicle collisions at low speeds. But there's also kind of an interesting public health challenge of, if we reduce overall traffic deaths for the entire population, it may be that some folks who will die in traffic accidents will be ones who would not have died if there had not been autonomous vehicles on the road. And it's very analogous to challenges that are out there in other kinds of public health interventions. And so it's a challenge that really requires a societal scale approach and policymakers to be engaged to make sure that the decisions that are being made by technocrats are ones that are backed up by policy.
No, it's really good. It's a very interesting topic. We used to discuss in a freshman class. I used to teach the risks of things like being killed in a commercial airliner, a modern commercial airliner, versus on the road. or by a texting driver, and the risk is huge, right? Disproportionate proportionate that, you know, the roads can be dangerous, and technology can really address a lot of those things. So that's good.
And if I can add one thing to that, we can really dramatically reduce our risk by avoiding places where people engage in risky driving. But it's hard to know, how can I drive in a way so that I'll never be next to an autonomous vehicle?
Absolutely. No, these are really good. Those are good questions. Yeah, I'm looking back to you. We have a major interstate corridor between Tucson and Phoenix. Are we working in this traffic corridor on research, on traffic flow, on sensors, and do we even have opportunities to link at the other end of that corridor with ASU on collaborative projects? So can you speak to some of these issues?
Thank you. It's a great question. So my team has been working closely with ADA, specifically ADA TISMO division, on developing innovative methods to improve mobility and safety for the entire freeway network in Arizona. So we work closely together in multiple projects. And in the recent project funded by Arizona Board of Regents at U of A, it was led by Dr. Larry Head. We actually work closely with the ASU and NAU, both universities, on improving the entire I-10 corridors beyond safety and mobility. We wrote a report and submit to a board. So that's something shows that we three universities actually can work together. That's why I put the other two universities in my center. So we do want to collaborate with them more closely in the future. In addition to ADA project, we also closely work with the other two universities on a project sponsored by Maricopa Association of Governments on evaluating new traffic technologies. So we actually work quite closely together. Thank you.
That's great. I mean, traffic safety, efficiency are certainly areas that touch every citizen of Arizona. So it's really nice to see the big universities in this state coming together. And I know that the Board of Regents likes that. And I know certainly that the lawmakers must like that. So thanks for moving those efforts. Jonathan, in a sort of a related area to autonomous vehicles, slightly different, but people have asked, can you comment on the efficacy of plug-in hybrid vehicles and how they can fit into this future transportation landscape?
Yeah, the plug-in hybrids can be extremely interesting for those of you who have solar panels in your house because it allows you to offload some of the solar panel information instead of having to store it in batteries to be able to store it in your car's battery. And there's even evidence to show that the output of, for example, nuclear power might be different if we knew that everyone would be charging their car overnight, because then the threshold for the nuclear stations could be set to be higher to avoid having to shed that data at different times. And so the plug-in hybrids also have tremendous benefits in being driven in areas where you want to reduce the amount of output from the vehicle. And it gives you that long-term benefit. If you really decide you want to go see the Grand Canyon, you don't have to get a different rental car to do that. You can keep going on that plug-in side.
And do plug-in vehicles offer any particular challenges in just general autonomy, or they just seamlessly integrate right in?
Almost any vehicle that has electrical regenerative brakes is much better from the perspective of actuation, because you lose some of the time delay in the dynamics that it takes to actually make your brake move. And so not only are you regenerating some of that energy, but you're also able to act faster, which can make it safer for you, as well as the ability to control traffic with that car is improved.
Good. That's the kind of technical nuggets our engineers like to hear. So thank you for that. Yeah, there's a movement around the world in the United States, which people refer to as complete streets, which involve the broader picture of what do streets mean to have safe access for pedestrians and bicyclists and motorists and transit riders. Now, where do efforts stand on the complete streets movement on the UA campus or in the city of Tucson or in general? And are you working on any of these areas?
Okay, thank you. So I do not specifically work on complete street topics, but I do work on complete street related topics, such as my team has been working on the pedestrian safety, bike sharing infrastructure evaluation, impacts of bike sharing, and e-scooters on transit riders. So we do touch some topics related to complete streets. And my job is to provide the data-driven evidence, provide the city with a data-driven evidence, so they can make their best political decisions. So in the meantime, as Jonathan just presented, Dr. Christy Currens is a professor at the Kepler our urban planning school. She has been working on some complete street related topics. We actually start thinking about some ideas to work together. So as Jonathan mentioned, we do want to do some interdisciplinary research so we can all work together like a big team.
It's good. It's really nice that's great to hear that as a university, we're, basically at the end of the day, people have to move around in society, and it's nice to see you addressing that just beyond just pure cars and streets. So we're coming to the end. Let's bring it back a little bit to education for a moment, because that's a big part of our mission. So we know that it's a competitive environment to recruit top graduate students, and they're very, very important to our program and to our mission. So can you talk a little bit, just briefly in your own experiences, the attractiveness of your research to attracting students into this, exciting area? I'll let Jonathan go and then Yao.
Yeah, the students are really attracted to areas, for example, in my case, of autonomous driving, because almost all of them have had an opportunity to drive a car, and they all think that they could do it better if they were a computer. And so this is one of those things that really excites me, because it empowers students to think about not just what can I do for a car, but what can I do for society at large. But certainly you've played, perhaps if you were young, a lot of video games of driving cars. You've all thought that you could be in a race and Fast and the Furious and whatever. Your imagination is captured so easily by the fact of just trying to do this thing that's seemingly simple. And it really opens the door to lots of educational opportunities and can make the University of Arizona a great destination for graduate students.
Great. Yeah, how is your experience again in enticing students into this really neat and impactful area?
Yeah, so fortunate, I'm faculty at U of A, which is a really good school. We actually try a lot of traffic. Traffic means internet traffic all around the world. Students take a look at my research result, and my research result actually fairly visual. They can see the result of my research and also know my research are pretty hands-on. So I not only can attract some students from internationally, and also attract some students, locally. So I'll be fortunate to attract those students. I think one thing I want to mention is that many applicants are from top universities around the world. I do want to attract them, but usually we do want to give them some incentive to accept our offer earlier. So I'm glad today we have some donors today, so we can actually see how can we incentivize those students to accept our offers earlier. Thank you.
Great, that's great. No, it's really, we often talk about the ability for engineering to impact society, and we know that students are attracted to areas of research that can have an impact, and that's great to hear that you're both successful. We're coming to a close. It always goes fast. I'm going to give you each about a minute to look forward, say 20 years from now, and maybe quickly what problems may have been solved, and what do you think the next challenge is? So I'll go with you, Yao, and then I'll give Jonathan the final word.
Okay, thank you, David. So when I watched the Back to the Future movies in the 80s, I thought there would be flying cars in 2015. At least Elon Musk at Tesla, okay, made autopilot possible, kind of technically and legally, kind of, okay. I think the new technology will solve the old problems, but it will create new ones too. So for example, autopilot might reduce the number of crashes for one crash type, but it might increase that of another crash type. In other words, we'll continue solving and creating problems until they converge. That's why your support, all of you guys' support to our research is critical, because we want to see they converge to solve all the problems. Thank you.
Thank you, Yao. And Jonathan.
Yeah, even though it doesn't sound that exciting, the integration of legacy cars into the automated transportation infrastructure is actually really exciting. And there's a couple of companies right now where you can buy something to retrofit your vehicle to turn it into a semi-autonomous vehicle. And as we see, again, this idea of convergence, that the cars are going to be getting smarter on one side, the infrastructure is going to be getting smarter on the other side. I think in 20 years, we'll get away from this idea of a single lane for autonomous vehicles and the rest of the lane for human-driven vehicles, and we'll have solved that issue of heterogeneous traffic.
Thank you very much. Look, I want to thank you both for really sharing your thoughts and your experiences on a really important topic that affects everyone daily. I want to thank our audience for coming. We had 200 plus people here, and most of you stayed right to the end. So thank you very much. I hope to see some of you back next week. And I want to wish everybody a great long weekend. Thank you for coming. Bye.
Thank you.